Hi everyone. Now we will look at this problem. It is a LeetCode problem, and the question itself is very interesting, but I think that the solution is much more interesting than question itself, because we will use a different technique, completely different technique. Probably some of you have heard about it. If not, you will learn about it in this video. So now let's start to look at the description. It says that given the head of a linked list, remove the nth node from the end of the list and return its head. And most probably you all know about linked lists. So every node is pointing to the next node. And as you see here also, we have like this pointer that specifies that. So every node points to the next node. And you can get the next node in the linked list by calling next on the current node. So if you are on this node at the moment, let's call it like a curve, like a current node. So if you want to get the next node, this node, then you can call current.next. And this is also what we have been given already here in this description, if you check. So it is all specifying how we can get the next node and also how we can create a new node. And one more thing which is important also in linked list, like when we reach to the end of the linked list, we need to be careful, because if we try to call .next, we will encounter null pointer exception. So that is just the introduction to linked list. Hopefully you have already understood the question, but I will go through it once again. So let me clean this text here. So the question is that we have been given an input, n is equal to 2. It is just an example input, and also the linked list as in the example. So it says that remove the second element, because it is 2 in the input, remove the second element from the end and return the linked list back. So as you see here, 4 is removed. So if we carefully see what has been changed here, we can see that, okay, 4 is removed, and also we said that next pointer points to the next node, right? Before 4 is removed, next node of 3 was 4, right? But after 4 is removed, now what we need to do in our algorithm is we need to point to the 5. So what we understand from here is next pointer of this node will be updated to the next. So what we understand from here is that if 4 is removed, the next pointer of this node will be updated to not to the next, but next. So we will do something probably like this. Next. And one more thing which makes it more difficult is that we don't know what n is. So in this case, okay, we know that n is second element from the end, but it can be also like maybe 3/4 elements from the end. So it can change, and also linked list can be like a 5, not 5, but a 10, 15, 20 elements. So now, before I jump to the solution, I will talk about the technique that I'm going to use in this solution. And that technique is called using 2 pointers. That's called slow and fast. It's actually a very impressive technique. I think you will love it. I really like this idea. It is usually used to find loops in linked list. So what is the idea of this slow and fast? Why we need 2 pointers? The idea is, so I will remove this text here so we can start again with the clean canvas. So we said that we will have slow and also fast, right? So the idea of using 2 pointers is that at first they will start from the beginning, so both will point to the first element, of course, and fast also. So that's obvious. At the beginning, at the first step, slow will stay in its place, but fast will move forward n times. So that means that if we are given n as 2, we will move it forward 1 and 2 times. So the starting point for the fast actually will be here. So I will remove this one, right? So we define our starting points for both of the pointers. So now I will just update the color of the pointers, so we have different colors, so we understand what's going on. So now what is gonna happen? We will create a loop, probably while loop, and inside the while loop, every time fast and slow will move forward one step. That means one node. So in the next iteration, fast will come here and slow will come here, right? And in the next iteration, fast will be here and slow will be here. And that is the place the iteration will stop, because there is no node after this one, right? So this is the last node that fast pointer arrived. So that means that we are already at the end of the list. And also with slow pointer, we already have the node that we need, because this is the important node. The next pointer of this node will be updated. That's why this node is very important. It's very crucial to find this node. That was all about the task. The rest is very easy, and you will see why it's easy. Here, let's say we will create some variable slow. What we will do is just we will update the next pointer of slow to be next pointer of the slow. So that is the whole idea. We already have the solution in whiteboard, and we will start now writing the code itself. So as we said, we already looked at the solution on whiteboard, and now we will try to convert it to the code. The idea is very simple. The only thing that is different is here. We will create a dummy node. This is actually a very common technique when dealing with linked list. The idea is that we are creating a dummy node because sometimes we can be asked to remove the head node also. So when head node is removed, it's not really convenient to update the head itself to the next of the head node. So that's why it's really great approach to create a dummy node. So we will use the dummy node as a start of the linked list, and at the end we will return dummy.next because that is the head of the linked list. You will understand more, and it will be more clear when we move forward with the solution. So let's start with creating the dummy node. And dummy node usually, like in this approach, we can create it with like a 0 as a value. So now this is dummy node. We will not return it in the response, but we will use it for our purpose. And dummy next will be head. So now what we did is, so we were given head as the head of the linked list, right? Now we created a dummy node and updated the next pointer of the dummy node as head. So now whenever we need the head of the linked list, we will return this one. So let's continue. We said that we will need 2 pointers, list node, and of course both of them will equal to the dummy and slow. So now we have 2 pointers, fast and slow. That's perfect. Now, as we said, slow will stay in its place. We will move fast by n times. We will start from 1 n times, but because we have one additional node, dummy, we will do it n plus 1 times. So fast will move forward n times. Perfect. Now we have fast and slow at its starting position. Great. The main thing is done. And now the rest of the algorithm. And while, what should be the while condition? You can guess maybe. The condition should be fast is not null. It's because if fast is null, that means fast is already beyond the end of the linked list. So that's why the condition is that we will continue this iteration as long as fast is not null. So the rest is easy. Both of them will move forward one node at a time. So we said that the rest is easy because we said that if we use this slow and fast pointer with this technique, the slow pointer will give us the node we need, which is one node before the node that should be removed. Okay, now slow next, which needs to be removed. So that's why we will update it to the next pointer of the slow node. So that should be all. And what is left is just to return dummy next, which will give us a head. So let's see. Probably we might have some syntax errors. We will see. So let's run it. So it's accepted. Of course, you don't see. I will just make myself smaller. So that's it. As you see, it's accepted. We need to submit in order to see if we have missed any edge cases or not. And that's it. As you see, it says that it is faster than 100%. So that was it, guys, for today. And see you in the next videos. If you don't want to miss out my videos, don't forget to subscribe and also turn on the notifications. Take care. See you in the next video.